let's take a closer look again at the binomial distribution. Again, the binomial distribution is for discrete random variables. As its name indicates, it has two values, A and B events, and it considers a probability of success P and a probability of failure 1 minus P. And we had said earlier that this is the most common example of a coin flip or something that's high and low. Coin flip obviously would be a probability of 0.50. Now, when a random variable with a binary outcome yes or no, or male or female, we use the binomial distribution to assess the probabilities of the outcomes. The binomial distribution will contain two parameters: the number of trials, n, that is the number of coin flips, and the probability of success, which is given as p. So consider we have a simple coin flip. We have 50 coin flips that we're going to do, and we want to know the probability of getting at most 30 heads. What we'll do is we'll use the Excel function to find the probability of the binomial distribution. Binom.DIST. K is the number of successes that we are looking for, which in this case is 30. N is the number of coin flips or trials. P is the probability of success. And we're going to have the cum parameter, which, if true, get us the probability of less than or equal to K as a cumulative. And if it's false, give us the probability of exactly K items. So in the case of above, we have the binomial.dist, where we have 30 for K, 50 for the trials, 0.5 for our probability of success, and true, which gives us 0.553. So there is a 55% chance of getting at most 30 heads. Now, it might not seem obvious, but you actually can calculate a mean and standard deviation for the binomial distribution. The expected value of a binomial distribution is given by the formula n, number of flips, times p, the probability of success. Consider that we have a coin flip as a probability of success 0.5, and we conduct 100 flips. We would have an expected value of 100 times 0.5, or 50 coin flips. And this is exactly what you would expect if you had done 100 coin flips. You would expect 50% to be heads and 50% to be tails, or close to it. The standard deviation formula tells us the variation of the successes will be around the mean. And the standard deviation formula basically says, well, we're going to take the number of flips and multiply it by the probability of success, and then multiply by 1 minus the probability of failure, and then take the square root of that. So in the coin flip above, the standard deviation is going to be square root of 100 times 0.25, which is equal to the square root of 25, which is equal to 5. And what this basically says is that, again, if I have a standard deviation, 68%, if I assume a normal distribution, but we'll use that term for now, that if we have the normal distribution, it will be one standard deviation is plus or minus 5 from our expected value. So that means we could generally predict, if we did 100 flips, 68 times, we would have the number of heads being between plus or minus 5 of the expected mean of 50. So it would be between 45 and 55. The reason this is important is because, again, as we have the law of large numbers, as we get more and more observations, there's a tendency to normal. And the same holds true for the binomial. And so we have three charts here to kind of show that. The first chart to the left shows the probability of just two outcomes. N equals 1, number of coin flips, probability of success 0.5. And so we end up seeing that we end up with the probability of the failure and the probability of success being 0.5. Now, if n is very large, we can estimate the binomial distribution by using a normal distribution. And you can see that on the right side because we have n equals 50. And what it begins to show us is the number or the possible values of the number of successes. So the graph below shows that as we increase n to 10, 10 is in the middle, it starts showing the elements of a bell curve. And that as we go to 50, it shows an even more pronounced bell curve. And so we end up, we can approximate our binomial using a standard normal distribution where mu is n times p as the expected value, and sigma, or the standard deviation, is the square root of n times p times 1 minus p. So if we want to calculate the number of successes, and we're given the number of trials and the probability of success, and we know the desired cumulative probability we're looking for, we can basically assume that we can figure out, using the coin flip example, the number of successes with a cumulative probability of 0.70, for example. What we do is we use the Binomial.INV function, Binom.INV, where we say Binom.INV, we have 50 trials with a success of 0.5, and we want to know the probability of getting at most 70, we want a probability of 0.70. We want to know the number of heads that are going to occur with a probability of 0.0. And it will result in less than 27 heads will occur with a probability of 70% or 0.70.